excited. This is our first core, and we're hoping it's a good location to give us some good information about the timing of this big expansion that we can see from other data. We should be getting the core on deck in a few minutes, and we've got everybody on standby ready to collect the core and bring it indoors and see what we got.
Yes, it is our first core, but all that's going through my mind right now is that I can't feel my fingers, so sorry, that takes precedence.
This is a tricky operation because you want to keep the sediment core intact as much as possible usually, depending on what you're doing with the sediment. So they'll lay it out carefully, and then we'll try and take the section away intact if we can.
We're getting the mud off of this piston core, and we just pulled it up from the bottom, and we drilled about 30 feet worth of sediment. We're gonna try and jiggle this off. Literally jiggle. Oh my gosh, this is so heavy. We're trying to wiggle the core loose from the thing that cored it, basically.
Am I the only one holding this? All right.
No, this is like the worst game of tug of war I've ever played. Okay. Come on, let's get muddy together.
You know, we've been working for over 12 hours from 1 AM today, and this is our 4th core, and there hasn't been a single complaint. Even though, I mean, it's muddy, it's cold outside.
We're getting a lot of data in an area where we do have some interest. We did not intend to get this much data in this area, but it just turns out that this is where we had a lot of open water. It's like this all the time in Antarctica. You end up getting data where you can. We're going to take a transect back towards Station 3, and on the way we're going to be trying to spot some core sites. We're going to take a jumbo on probably Station 3, which is the furthest one away. It might be like 7 miles, and we want to get 8 barrels for that site, okay?
Copy that, 8 barrels.
Hello?
Hey, honey.
Hey, Mom.
I got your email today about chlorine.
We're trying to set up for the jumbo piston core, and that's like, we're gonna try and get 80 feet. So that's gonna be really exciting, yeah.
So we had very good luck coring a similar site where we got 28 feet, and we know the unit that we cored into is as much as 60, and we're hoping to get all the way through that unit and into the underlying sediment, and we'll just have to keep our fingers crossed that it all works out according to plan.
We sent down the jumbo core, and as it went down, it must have hit something really hard. The jumbo core was bent. Hopefully we have something. We're not really sure. It might not have picked up anything because the sediment may have been too hard, but we're hoping that we're thinking positive, and we're hoping that we have something.
Because, well, we were hoping to get at least 30 feet because we saw something on one of the recorders indicating there was an important transition at that depth. So each one of these segments is 10 feet long, and you can see where the bend is. It's right in the between 20 and 30. So I don't think we got down far enough to get to that interval we were trying to sample. But we have more barrel. So we're just going to lick our wounds and go try to identify another site where we can try to get it. We'll just see what happens. Go down again. Yeah, there you go. That's it. Stop. Good. Down. Get it.
The only 4-foot core is really good because each glacial period leaves its own mark on the seafloor, and using a jumbo core you can find out how those two sediment layers are related. So instead of sampling them in two different places, you can see how they meet and how they come together, and that can help you date the difference between the two much more cleanly, and also tell what sort of conditions existed when one glacier advanced over the other. Unfortunately, this is the second time we've tried it. This is the second time we've bent the core head. Probably what's happening is that currents deep in the Ross Sea are pulling the coring tube that we can see here at an angle. And because it's got a big weight at the top that drives it into the sediment, if it's coming at an angle and that weight isn't centered just above the rest of the tube, it can bend it, and then as it comes in, that extra weight bends the tube. So this has been really bad for us, not just because we don't get the full sediment core, so we don't see all the sediment we want to see, but because we're only here for a really short period of time when you add it up, only a few days for coring for each of these legs. This really sets us back. It really stops us from getting all the samples we want.
Might be able to get about that much data with if we go back to multi-beam now. We're going to have to leave in less than 48 hours. So I've kind of put together a little chart kind of showing the amount of distance we could cover in an hour. 2 hours of travel time at 10 knots, we can cover 37 kilometers. So this is a really important patch here. So that'll give us at least this edge, get a lot more coverage on here. It's such a big area, we're really going to have to get the community behind trying to do this sort of effort. We'll see what happens. 24, 48 more hours, and hopefully we have a nice data set in hand at that time.
If you hear that, that's the crushing of the ice right now, and it's just something you don't see every day, and I don't think I could ever get used to this.
Oh, look at some more wheels.
Well, I'm a geologist, and my specialty is rivers of ice, but there's something really magical about the animals.
I really wanted to come because I felt like this was a lifetime experience. I know that a lot of people don't have the opportunity or the means to come to Antarctica, and so I knew that it would open my eyes to a lot of things, and it's just incredible because you can never see this anywhere else, and I think that was the main reason to help connect me with global warming and what the processes are in Antarctica and how it can change everyone in the world.
I think I've seen everything that I wanted to see before I came down here, so it's far surpassed any expectation I had before.
Also, the science was good. I think we made some progress. We had problems with the cores. It's really interesting what's going on down here. It's really different from a lot of other places. The ice sheets are so big, they make such a different impact on the environment than almost anywhere else on Earth.